Perfect. What's up, X-Man? Did you have more water polo today, or was that was just yesterday? You had a weekend of games. You had so many games. You got a power outage today. I'm pretty sure it fried 2 RAM rails. I hope it didn't, like, fry the RAM. Do you know the price of memory right now is insane. You know that, right? All the AI people are buying up all the fucking memory sticks. It is the worst time to build a computer. AI, like, literally made it the worst to try to build computers. Because, I mean, first we had the graphics card insane prices, and then those kind of like came down a smidge, and now RAM prices are insane. What's up, fam? The sticks are fine, it's just the rails. Okay, great. Yeah. Okay, cool. All right, let's do this question. This is from 1K. Looks like chem. You got a chem file coming up? I know you did really well in your exam, by the way. I saw that. That was under... Where do we have that? Here in good grades? Yeah. So we reward people if they do well in their classes.
I am not late.
You are not, dude. What's up, Chuck?
Can I do my intro?
Give me 1 second. 1 second. 1 second. 1 second. Oh. 1K. Nice job here, by the way, dude. Getting basically like a 15 out of 15 on your chem exam. This is sick. All right, nice. Okay, cool. Shaq, go make the intro. You're good. Do it.
What's good, stream? How's it going, everybody? Welcome to the actual education hour. Welcome to the teach-a-thon. Welcome to the stream of education, of learning. Today, your host, Dr. Gold, the host has been here for many years.
Many years.
Probably almost half a decade now. We'll be teaching you for the next, how long? 2.5 hours?
2 hours and 36 minutes.
That's dope. 2 hours and 36 minutes. Of his time. I don't want to sound cocky or anything.
It's okay. You can be cocky.
But for you guys to get free education, bro.
That's crazy.
Rewards and free prizes too.
Hype.
So,
fuck yeah, dude.
Yeah, okay. Lock in the stream, guys. Have a great stream. I will catch you guys later. I just want to do the intro.
You're good. I appreciate it. Thank you, Chef.
Have a good one, guys.
You too, man. Okay. Find the pH of the following solutions. This is cool. So, I think what we have to do is first classify whether these are strong acids or weak acids. Yeah, dude, I love it, chat. Thank you. Chat loves it. HCl, hydrochloric acid, that's a very strong acid. So when you have strong acids, what happens is that they dissociate completely. So HCl, for instance, will break up completely into H plus and Cl minus. Okay. The other common way they sometimes write this is like with H2O. We're not gonna, that's like the difference, I think, between like Bronsted, Lowry, and like whatever acids. But in general, yes, this acids usually have hydrogens attached to the front, and if they're strong acids, which HCl is a strong acid, they dissociate completely into what are called their constituent ions. So in this case, we get an H plus and we get a Cl minus. Oh, 1 sec. Let me make sure the TikTok chat's working. Should work. Come on. Okay, good. That's great. All right, so that means if there's 0.25 molar of this dissociating, then there is going to be 0.25 molar of this. And there's also going to be 0.25 molar of this. Right? Nice. Okay. So then, in order to figure out pH is just equal to the negative log of, this is called the, it's not hydronium, because hydronium is H3O plus, which is what happens when, like, H2O, like, dissociates. It dissociates into, like, H plus OH minus. And then I think you can, like, pretend this connects with another H2O to give you, like, H3O plus. Yes, exactly. Exactly, Psychode. Psychode's correct. So, in this case, the hydrogen plus concentration we have is 0.25 molars. So all we have to do is just do negative log of 0.25. And let's go find the calculator, because you can't do this in your head, unfortunately. Unfortunately, yeah, this is difficult to do in your head, but we can do it with a calculator. So I can just do... And also make sure this has to be log base 10. It is the log of 4. Zach's not wrong. Also, wait, why is my keyboard not working? Sorry. Excuse me. Okay. Negative log of 0.25, which Zach is right, is also the log of 4. Yes, the log of 4. So yes, it's 0.6. Which, wow, that's actually a really, really acidic thing. Dude, okay, hydrochloric acid don't fuck around, dude. It's chemistry, X-Man. Have you taken chemistry yet? Nah, you haven't? Okay. You've heard of acids and bases, I'm sure, though, right? Like things that are acidic and things that are basic. Like some examples of acidic things would be like lemons. Lemons are acidic. Coca-Cola, like the soda, is acidic. You can actually like drop things in cans of Coca-Cola, and if you leave them for like a week, they completely disintegrate. It's pretty crazy. Yeah, the citric acid in Coca-Cola is really caustic, actually. This is probably high school level. Yeah. So one thing to measure how acidic something is to look at how many H pluses it breaks down into. So this is another interesting one. Okay, so now we have H2SO4. There's a funny rhyme with this one. What is it like? Tommy was a good old boy, but now Tommy is no more. What Tommy thought was H2O was actually H2SO4. No. Basically, like Tommy drank hydrosulfuric acid instead of sulfuric acid, sorry, instead of water. So yeah, H2SO4. Nice. You use HCl to dissolve solder. Yeah, that makes sense. Soldering is dope. I love soldering shit. It's great for electronics and stuff. Yes, anything above 7 is a base. Well, 7's neutral, technically. So I think like 8 and above. Like we call neutral, I think, between 7 and 8. Yeah, something like that. So H2SO4, that's going to break up into 2 H pluses plus an SO4 2 minus. So this is where you have to like balance your reactions, right? So if this is going to be 0.25 molar, then this is going to become 0.5 molar. And then this is 0.25. The reason is the coefficients. So the molarity of this is 0.25. So you're going to have 0.5 molars of H pluses. Because for every one H2SO4, that produces 2 hydrogens. So you have to double this number, actually. So in this case, this is the negative log of 0.5. Which, let's see what that gets us as a pH. Negative log of 0.5. That's going to be 0.3. Wow. Even crazier. And we can look at that, actually. Let's just say, like, you know, hey, what is the pH of 0.5 molar H2SO4? Oh, did it say 0.025? Oh, I fucked up. Oh, wow. Dude, that is tricky. Oh, I thought that was a lot, actually. Thank you, 1K. Thank you, everyone in the chat, for, yeah, I told you, I'm cracked out today. I am in go mode. So, if I see things, I'm just going to go do it. Thank you. So, yeah, so actually, what does that do to this, right? So now this is 0.05. Okay, so actually not as crazy. Because I was wondering there, I was like, wait, why is H2SO4 like so much? Can I do one with a weak acid? If you submit a question, I'll do it. Yes, because that determines doing pKa. This is also a weak acid because only 1.3% of it ionizes. Okay, so yeah, let's do that correctly. Okay, so if we do 0.05, that gets us 1.3. Okay, that's more reasonable. Isn't this Beer's law? No. What is Beer's law? I remember we used to joke about Beer's law in like college, but Beer's law in chem. No, Beer's law has to do with absorbance. This is for like shooting light through a solution, and then the amount of light that transmits through is related to the absorptivity and just basically the concentration. What's up, Bing Bong? Bing Bong. Logarithmic functions in chem. Yeah, dude. A lot of things in chemistry are logarithmic. A lot of things in chemistry are logarithmic. Calculus students versus the algebra mistake they make. Dude, I love that, Machko. Your exam was fire? Good. Like, fire in a good way or fire in a bad way? Okay, let's do this. Ooh, interesting. So, this is actually kind of complicated. Because, they're giving us grams and they're not giving us molarity anymore, right? Okay. So, what I know, this is acetic acid, by the way, which is, correct me if I'm wrong, is that vinegar? Is vinegar acetic acid? So, this is going to dissociate into some H+, and this is called acetate. Yeah, oh, it is acetic acid. Oh, okay, cool, very cool. All right, I knew that, right? O2 minus. But, I don't know, I think we could, do we do like this? Right? I think it's like an equilibrium reaction, because, like, not all of it goes that way. Right? Anyways. So, we know we have 2.95... This is chemistry. We have 2.95 grams of this, and only 1.3% of it actually ionizes. What's so busy, super handsome? I don't know what that means. Okay, so, the amount of H plus here, right? We can find the moles of this, and then only 1.3% of those moles are going to go to here. It is chemistry. Okay, so we need the mass of acetic acid, which I'm gonna be lazy and just look it up. Yes, you do need to convert it first. So 60.052. Okay. So I want to know, like, how many moles is equal to 2.95 grams of CH3COOH. This is like this is the other way to write this. Your centripetal forces video got me 100 on my test. Fuck yeah, dude. That's awesome, Matthew. I'm happy to hear that, dude. I need to make more of those videos. That is one of my things that I'm taking out of Zach's book for changes to the stream next year. I have to dedicate more time to making those videos. All right. So this was what, 60.05. We can just say 60 grams per mole. Whatever. It's close enough. 60 grams in 1 mole of CH3COOH. Do I teach? No, I teach a lot of math. Tons of math. It's just the first question of the day today was chemistry. Yeah. But I do a ton of math. Yes, the video helps a lot to look back on things when needed. Sick, dude. Nice. Kisei has his circular motion test on Thursday. Good luck, dude. Yeah. Yeah, I mean, that's the point of me. That's why I create those videos, is because, well, I mean, a lot of people are just doom scrolling through shit, and I would love for that to just pop up on their feed and be like, oh, wait, this is related to, like, what I'm doing. But also as a reference of, you can just keep watching it over and over again, and that can kind of be studying. Just to, like, refresh and, like, figure out how to do it. And I try to put it in, like, a straight to the point, no fucking bullshit. I hate all these watch time farming videos, you know, when they say, like, we're gonna do this, and then they spend like a minute describing what they were gonna do, and you're like, come on, bro, wrap it up. Like, where is the answer? Like, or where's the juice? Like, why am I watching your video? I'm like, no, screw that. Just like, here's how you do it. Yeah. Significant figures is crying. Yeah. I know. I am screwing with the significant, but this is basically 0.05 moles. Okay. All right. Since this is 1-to-1, this is also going to be 0.05 moles, and we're not done yet because I need molarity technically, but we're going to get there. But I know that only 1.3% of it ionizes. Okay, so I'm going to do 1.3% of the 0.05 moles. And so that's going to be 0.013 times 0.05, which I should know this. What is this? This is 0.0065, I think. Right? 5 times 13 is 65. And then there's like a couple zeros. Actually, I think there's even more zeros. Sorry, I think it's 0.0065. Let me just check that. Yes. Good. Okay. Cool. So that's the moles of H+, but in order to do pH, we need the molarity. So I'm going to divide that. So molarity is equal to moles over volume. And this is where you have to ask yourself, like, okay, well, how much liquid is there? So this is a simple thing, because they only have one thing that's dissolving. A lot of times I'll have, like, 2 different things that are adding together, and you need to add the volumes of the liquid to each other as well. But this is just a single thing. And it's 500 mLs. 500 mLs is half a liter, because volume's always in liters. So we're going to do that. We're going to do the 0.0065. What level of math do I do? Up to, like, diffie-Q. I can do some complex analysis. But I have other friends who are in my chat, in my streams, who also have math streams, and they can for sure do up to, like, graduate level math, I would say. So I tell people, ask whatever. Like, I can probably solve it. Oh, fascinating. We go back up to 0.013. Is that real? Yeah, I guess we do. Oh, wait. I'm missing a couple zeros. Sorry. It's 0.0013. Scientific notation is having a terrible time right now. Thanks. Yeah, I did forget a zero. If you submit a question on Newton's law, I'll do it. Riemann hypothesis, that is a joke. Isn't that like a Millennium Prize thing? You guys are always like fucking with me on that one. Yeah, and we do skip JEE problems. I generally do not. Dude, I looked at the timer that we did on that JEE problem the other day. And it was 30 minutes. We spent 30 minutes. We didn't even get the right answer. We didn't even get the answer. But I was still happy about it because we learned a lot along the way. But that's why I generally have a ban on JEE problems. Just because they take up way too much time for a stream. They are very cool to like do on your own on a rainy night and to like build some character learning math. But I think for this format of education, JEE is absolutely like it's garbage. It's unfair too to anyone else who's like wants help and has to wait 30 minutes for me to figure out how to solve the, you know, poverty escape exam. Anyways, you do math on rainy nights for fun? Yeah, fuck yeah, why not? Yeah. And they do have a lot of steps. Yeah, they're just tedious. Okay, answer here should be 2.89. Great job. Wow. Yes. Good question. 1K. Okay. You're very welcome, dude. All right, so what I'm going to do is I'm going to save that screenshot of what we did there. And this is why y'all should go join the Discord. If you're watching right now, go join the Discord. Also, the website, if you want me to help you with anything, submit a screenshot to this website, actualofficehours.com. Put in your username, drop in some sort of picture of preferably like a homework question, a test review question, or even like a previous test question. And then I can know what level of help you need. You know, like how far do we need to go down? But also there's a link to join our Discord. When you go do that, you will then get access to our wonderful and awesome, amazing community. And on there is a channel here called Homework Help, where all of the questions we go through today. So even if some things get submitted to the queue, I run out of time, everything gets put in here eventually. And we post the solutions to what we have. So here we go. So this was 1K's question. 1K's question's right here. And then I'm going to drop in the screenshot for what we did. So there you go. There's 1K's question. There's the answer for them. And then also, because 1K is a member of our Discord, we also give out points for everyone who asks a question. And you can use these points to buy any sort of gaming gift card. So Robux, V-Bucks, Xbox, PlayStation, Steam, I don't care. Anything gaming related, we incentivize you guys to like do well in school and life. So join the Discord. It's awesome. Cool. All right. Lath, you keep asking me to explain Newton's laws. You need to submit a question on Newton's laws. Then I'll do it. Incerner. Okay, cool. This is a pressure question. I love this. This is great. Okay, this is more... We're doing physics now. Love it. Okay, a stream of water flows through a pipe of radius 3 centimeters and then into a smaller pipe of radius 2 centimeters. If the pressure difference is 3 kilopascals, what is the velocity of the stream as it flows through the small pipe? Cool. This has to do with Bernoulli's equation, I believe. Right? I think we have to use Bernoulli's equation. So let me go get Bernoulli's. Yes, Stokes, Green's, and divergence. Although, I feel like Green's is just a 2D simplification of Stokes. Correct me if I'm wrong. And then, yeah, you're more than welcome to help each other in the chat. But also, like, you could just join the Discord and post questions, then other people would help you there as well. It's sometimes hard to, like, do things in chat. Especially because the chat just, like, keeps running like crazy. All right, so this is the main concept you need to know. This is from the wonderful website Hyperphysics. I love Hyperphysics. It's such a low... It's such a... Where is it? Where's my Hyperphysics? Hyperphysics is such a low-res website, but I love everything about it. So if you ever want to learn physics, Hyperphysics is great. They do everything in kind of this awesome... like, tree of knowledge. So you're like, oh, E and M? E and M is related to electric charge. Electric charge is related to Coulomb's law. Okay, within Coulomb's law, you can then learn about Gauss's law, and then, I don't know, it's a wonderful way to show, like, all knowledge is, like, all connected. But this question, cool, says that the total pressure due to a bunch of different things beforehand has to equal the total pressure due to a bunch of other things afterwards, okay? Yes, dude, Hyperphysics is a classic. I think it's slept on these days, because, I don't know, people think it looks like old school and like a scam, but it's dope. I used Hyperphysics. I still use Hyperphysics. We used it today. So, all right, P1 minus P2 is equal to 3 kilopascals. So let's write out all of this and then see what the terms are we have. So, okay, we have P1 plus 1/2 rho V1 squared plus rho GH1 is equal to P2 plus 1/2 rho V2 squared plus rho GH2. Yeah. Dude, the hyper ADHD noises are for my audience. They just love them. I can't tell you how many times I've gotten reviews, both like in my lectures and also like on my YouTube videos, where people are like, thank God for the sounds, because that's what keeps them involved. I know to millennials or like older people, they're like, yo, stop it. But trust me, Gen Z and the Gen Alpha, they love it. That's just, you have to do it. All right, so let's look at situation 1. Situation 1 has a certain pressure, which is higher than pressure 2. So if we wanted to move this over, right here, let's just copy this all over so we can see like what we get. I can take this, I can move it over here, and now we have P1 minus P2, which we have a value for that, by the way, right? We know that's equal to 3 times 10 to the 3 pascals. Okay. Let's look at the other terms here. Rho GH1, rho GH2. This is the gravitational term related to the height of the liquid. Because they don't give me any heights here, I'm going to assume that the height is constant. And I think it refers to like the center of the column. So you can see here that the center of the column is pretty much the same in situation 1 and situation 2. Where the height difference comes into play is like sometimes you'll have... what's that thing called that measures like... it's like fluid. It's like they use it on airplanes to measure how fast you're going in an airplane. Anyone know the name for that? Where are my aerospace engineers? Is it called a pitometer? No. Fuck. Airspeed. It does. A pitot tube. Thank you. Thank you, Incerner. Yeah, a pitot tube. Yeah, this is a great example. Yeah. Yeah, so they use pitot tubes to measure... Here, this is cool. Yeah. This is how they measure how fast airplanes are going. And so in this case, you do have like differences in height. And so there are like some equations used. Yeah, it's called a pitot tube. Yeah, very cool. This is fluid mechanics, yes. So we're going to assume that the heights here are the same. So those are going to cancel out. And then we're left with this. Rho V1 squared, rho V2 squared. And... let's see. We're solving for the velocity as it flows through. So we're looking for V2. An unladen swallow. That's a Monty Python joke, isn't it? Dude, I bet nobody here really knows what Monty... Well, I do have some older people in my stream, but I don't know if the kids know what Monty Python is. It's a great one. You have a physics test tomorrow. Oh, good luck, dude. Damn, I had this yesterday. Yeah, the algorithm always knows what's up. Okay, so we're looking for V2. Are we given V1? We're not. Okay. But, okay, that means we're going to use flux, aren't we? Yeah, I know what we're going to do here. This is kind of funny. Okay, all right, fine. We're going to have to use conservation of flux. You have a chem test Friday. Good luck. Good luck with chem. If only I had your page last year. Well, now you have my page for next year, because I guarantee you that there's something else on my page that you're going to learn next year. Like, I do everything. Okay, so we're looking for V2 squared. We're looking for V2. So far, let's, like, move all this over. Also, yeah, no, okay. Okay, so 3 times 10 to the 3 plus 1/2 rho V1 squared. And then that's going to be divided by 1/2 rho V2. Sorry, rho. This is equal to V2 squared. Are you a professor? Yeah, I did teach at UCLA. I don't teach right now. And I'm not teaching in the future. But I have taught at UCLA. This is Bernoulli's. Yes. Okay, great. Nice. Okay, so now we need to get V2 squared. I assume we're given rho. Yeah, they say water, so rho for water is equal to 997. I taught physics 5A. I need V1 squared. So this is where I need another relationship, and this is called conservation of flux. Which says, if you submit your question to the screenshot, to the queue, Johnny, I'll do it. Just submit it to the queue. The queue's only 4 questions long. Fluid flux equation. We may not even need Bernoulli's. I feel like we do, though. Sorry. Fluid flux conservation. Where is it? Now, yes, there we go. Where is it? Q. Yeah. All right. Q is V times A. Yes. Okay. Velocity times area. That makes sense. Okay. So, flux is Q. That's equal to V times A. Actualofficehours.com. Website. It's right down there. It's on. I can't post links in TikTok because they don't like it. But the website is pretty easy to type in. Okay. So that means that V1A1 must equal to V2A2. So interesting. Do I even need any of this? I'm curious what the 3 kilopascals means. I have a degree in physics. My PhD's in physics. Yeah, right? Okay, cool. Okay. So, and then this was situation 1. This is situation 2. Yep, okay. So, V1 times pi R1 squared is equal to V2 times pi R2 squared. And then, I can just solve... Wait, I can just fucking solve from V2 here. Do we even need this? Wait, what? Can I really just do conservation of flux? That's crazy. Where is this? We're in Cerner, right? I can do basic circuit analysis. Don't ask me, like, Thevenin circuits or stuff. Circuit analysis 1, probably. My thesis is published. If you go to the same website, here, go click on bio, which is down here. That'll give you a link to my thesis, my LinkedIn, anything your heart desires, it's there. Yeah. The upholstery formula? What is the upholstery formula? Okay. Oh. But we're not given the velocities. Got it. Okay, that's why. Okay, cool. Awesome. Got it. All right, so V1 is going to be equal to, so we can cancel out this. And that's going to be V2 R2 squared over... this is why we need both of them. Where are you from, handsome? I don't know where... I grew up in Texas, I guess. I don't know. I live in Los Angeles. Okay, and then R2... So the radius of the second one is 2 centimeters, right? So that's going to be 2 centimeters squared, which is going to be 4 centimeters squared. And then this is over 3 centimeters all squared, so that's going to be 9 centimeters squared. And then this is V2. Whatever, units cancel, so you just get 4/9 V2. Oh, beautiful. Okay, awesome. So now... Oh, I see. I need to actually separate this. Oh, it's annoying. Okay. This is important. Because now we're going to plug that into here somehow. It's number 5? Okay, Johnny. Thanks, dude. Yeah, hang around. I'll do it. We got 2 hours to stream today, so I will make sure to do your questions. Okay, so now I can substitute in V1 with this. So this is going to be 4/9, which is going to be 16 over 25 V2 squared. Okay, so now I gotta like separate because we gotta get the V2 back over here. Yeah. Do we know the difference in velocity? No, we don't know the difference in velocity. We know the differences in the radii and the differences in the pressure. I know the ratio of the velocities, right? Okay. So this is 6 times 10 to the 3 over rho. This cancels. And I'm going to say plus 16 over 25 V2 squared equals V2 squared. So now I can move that over, right? And so that tells me that 6 times 10 to the 3, rho for water is 997, is equal to 9 over 25 V2 squared. Square root. Well, actually, let's just move this over real quick. So this is 25 over 9. Now you square root this whole thing, which this is going to be 5 over 3. Or sorry, yeah, 5 over 3 square root of 6 times 10 to the 3 over 997, and that's going to be equal to V2. Let's see what we get for that. Lucky Los Angeles. Yeah. I mean, I don't know. My rent's fucking expensive. Yeah, I mean, the weather's great. But trust me, bro, the rent is not cheap. Okay, that and then divided by 997. Then we're going to do that times this, right? Cool. All right, so we get, what is that? 4 meters per second? Is that what they wanted, by the way? Sorry. What do they want? Yeah. Okay, cool. So it should be this final choice here. And that should be this. In Cerner, what degree are you studying for? Okay, I think it's the last one. Nice. Great. Good job. Cool. Kind of a longer one. You had to use Bernoulli's equation, and then you had to use conservation of flux. In Cerner says he's a mechie. He's a mechanical engineer. Fun question in Cerner, though. It was a good reminder to me of, like, you are special. The high-end places are suitable. I love these compliments I'm getting. A7 Meds, dude. That's a funny name. All right, let's mark this done. We're going to go put this in our Discord. Again, join our Discord if you want to see any of the questions that are being answered and the solutions to them. I'm thinking about putting a cool little new feature that when we post a question, it also posts the timestamp to where this is in the stream so that someone can go back and watch what happened. Oh, yo, you're Kemi? Kemi's dope. One of my best friends in college, I went to UT for undergrad, was a chemical engineer. You can make bank with a Chemi degree, especially if you're in Texas. Okay. Mathematician, what's up? Are you still asking for the upholstery question, dog? All right, Kasey, let's do this. Ooh, this looks like physics. You guys are all unks. I'm still in high school. Yep. Yeah, no, I'm 35. Like, I'm super unk. Learning happens at all ages, though, you know? And it's, dude, some people in my server are, I think, in middle school. Can you ask a question on my thesis? You can DM me. Maybe, like, not here. I gotta do all these things. The upthrust formula? I don't know what the upthrust formula is. That sounds like an engineering thing. Okay. The other half is thermo. Dude, thermo, ugh. Thermo hurts my soul, dude. Okay. This is from Kasei. All right, so let's see. A point mass is moving in a horizontal circle with a velocity v and of constant magnitude. Okay, great. At one particular time, the mass is at P. At another short period in time, the mass is at Q, as shown below. What diagram correctly shows the change in velocity of the mass during this time? Okay, cool. So delta V is always equal to like V2 minus V1. This is how we write things. I'm gonna call this V2. I'm gonna call this one V1. All right. So V2 is pointing this way. So we can call that like one of the V's. And then minus V1. So minus V1. V1 was pointing to the right. So minus V1 needs to be doing that. So here, this is like V2. This is actually kind of cool. This is going to be minus V1. And then they want you to probably figure out the summation of that. So this is cool. This is vector addition. Okay. So if you want to add vectors to each other. So for instance, if I need to do, let's say I have this. Let's say I have a vector A and I have a vector B. That's, I don't know, let's say something like this, right? If you wanted to do A plus B as like some new vector, let's say C. And I know these should all have fancy arrows on them. Whatever. Pretend they're bold. All you have to do is take the beginning of this vector, which is here, and then place it on the end of this vector, okay? So, in this case, this would be A. And if we wanted to add B, we would then take B and we put the beginning of B at the end of A. All right? And then C, this is called the resultant vector. This connects the beginning of this to the end of this. And so that's going to go from here to here. So you see how this is the beginning of this one, and then this is the end of this one? So this is an example of A plus B is equal to C. Is this pre-recorded? No, dude. This shit is live, dude. It's a live stream. Why would this be pre-recorded? Sifulia. Okay, so if I want to do this is interesting. If I want to do V2 minus V1, V2 minus V1 is the same thing as V2 plus negative V1. That's why I wrote this as negative V1. Because now, if I want to add negative V1 to V2, all I'm going to do is take the beginning of V1, or negative V1 in this case, and put it at the end of V2, which is right here. And then my resultant vector, which is what these things equal to, so that's delta V, that connects from the beginning of V2 to the end of negative V1. Pre-recorded chat. We do it live, goddammit. Shit fucking sucks. Who's that guy again? What was his name? Man, I think, what was his name? Was it Bill something? Not Bill Nye, the science guy, obviously. He was on Fox News. He was hilarious. Physics can't be that difficult. I mean, it can get difficult. All right, so, sure. So this is the answer. I don't see what's happening here, though. Which one does this look like? Bill O'Reilly, there he goes. Where can you ask about my thesis? You can DM me, that's fine. I also didn't draw these exactly correctly, right? Okay. I think this one is equivalent to it, technically. Yeah, I think the answer choice is this one. Yeah, I'm tempted. I'm tempted to say the answer choice is this one. It looks different than this, though, I will say. V2 minus V1. Okay. That is right. This is what I would have liked to have drawn. But I guess the ordering can be whatever. I don't know. At the end of the day, the resultant vector needs to point always towards Always towards the center of the radius. Yeah, I think the bottom left is correct as well. It looks kind of weird how they got that though. They did this one plus this one. I don't like that. No. I don't like that at all. That's just weird. I guess it's technically correct because, right? You have like this going this way and then this going this. But bro, what? No. No, what? Because yeah, I don't like this. But this is the correct answer. Kind of weird. Isn't that weird, Fem? How they did that? Right? This. Yeah, they added the opposite, I guess. But there are other methods, I guess. Sure. So wait, what's happening here, by the way? This is like, this is P plus like R is equal to Q. Okay, so Q minus P equals R. Okay, I get it. I guess it works. That's kind of garbage. 89.5 on your AP Calc test. Nice. Good job, Johnny. All right, I don't agree with how they did this. This is the better way to look at it. But at the end of the day, you just need to make sure that delta V points inwards towards the center of rotation. So, cool. Interesting question, Kasey. No, they are the same thing. No, Megan, you are right. They are the same thing. It's just I wouldn't intuitively have got it that way. Yeah, because, I mean, what they're saying here is they're saying, okay, if this is negative V, then this is positive V. And then they're saying this is also positive V. And then this is delta V. So technically you could have added the triangle like this, I guess, right? You could have done this. And then this is the delta V. It's just gross. It's the same, but I don't like it. What's up, Usagi? Good to see you, bro. I have 20 minutes to do like this in well. Okay. So Kasey, what's up, Alice? Oh, Alistor. Oh, that's your Twitch name. Okay. Okay, so I explained like in depth how you would do this, right? The formal let's teach you about, you know, adding and subtracting vectors, blah 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 blah. If you just need to complete this question in a minute, the first thing you should know is that change in velocity. So change in velocity per unit time is equal to acceleration, right? You should know this. And acceleration for something that's moving in a circular direction needs to be centripetal and always point towards the center of the rotation. So looking at these questions, the only one that has delta V pointing inwards towards the center of rotation is this one. So you can just like, these are just wrong right off the bat. And then you just know it's this. As to like how this works, I don't know, it's gross. I don't like it. I think that's IB physics for Kasey, right? Is that IB physics for you, man? Correct me if I'm wrong. I think it's IB physics. All right. Good. All right. Kasey's question. Going back into the queue. Your teacher taught us both ways. Yeah. Yeah, it's IB physics. Okay. Makes sense. Boom, 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 boom. All right, what we got next? Suba. Ooh. Yeah, they did V naught plus dV equals V1. Yeah, I get it. Which is technically V1 minus V naught equals dV. Yeah, I see. It's just weird. Right? It's just like a weird way to do it. They're about similar, Johnny. I think IB is technically a little easier. It's weirder, though. I mean, if you're in the US, you don't want to take IB. You want to take AP. Okay, the propeller of a boat, okay, will rise and fall with the waves on a particular wavy night. The propeller leaves its resting position and reaches a height of, well, the propeller is also spinning. Wait, what?
You done messed up, Aaron!
Okay. Okay, fine. This is kind of weird to think about. Like, usually you think about the propeller is like you think about one of the blades on the propeller and how, like, it's going up and down. In this case, they're talking about the boat and, like, the propeller is fixed. And they're like, oh, how does this, like, move up and down with it? Yeah. Yeah, it's docked. Where does it say it's, well, it's at a dock. Okay, so the propeller's not moving. Valid, Jorge. Valid. Okay, fine. Okay. First of all, I'm gonna break this up into 2 questions because I can't deal with this. This needs a good way. Okay. All right, 2 meters at the peak, -2 at the troughs. So that tells me right away the amplitude is equal to 2 minus -2. That's equal to 4, right? So the max minus the min is, oh, and then you have to divide this by 2. Sorry, divided by 2. So 2 is the amplitude. Yeah. So this is max minus min, and then technically you need to divide by 2. That's what amplitude is. Okay, the time between the peak and the trough. The time between the peak and the trough is half a period, okay? So delta T from, like, peak to trough is equal to 1/2 of a period. And then they say that's equal to 3 seconds. So period is equal to 6. And then they say at t equals 0, it's at its resting position and heading towards the peak of the next wave. So that's great. So we know this is a sinusoidal. Sine looks like this. Okay. It starts at 0. So at t is equal to 0, you're already at the what the fuck happened here? You're already at the equilibrium point. Wait, what? Dude, what? Why are you drawing weird spikes on my stuff? And it's heading towards a peak. And then you can say that, like, this amplitude here is 2. Okay, and then we know that half a period is equal to 3. So going from is this called a node? Going from a node to a node is also the same thing as half a period. So this is also 3 seconds. Okay, cool. So the equation for this is y is equal to a sine omega t, and then plus c. This is usually like the midpoint, or the midline, I think is what they call it. In this case, the midline is 0 because it's symmetric about 0. Amplitude is equal to 2. Omega, okay, so omega is equal to 2 pi over the period. So in this case, that's 2 pi over 6, which is equal to pi over 3. So this is 2 sine pi over 3 times t, and you're done. Okay, so that's how you figure out the sinusoidal for that. All right, then here, let's do your second one, because I feel like this one's not too bad either. Trampoline. Owen is jumping on a trampoline. When his feet hit the deck of the trampoline, the material depresses to a minimum height of 2. On average, Owen is reaching a maximum height of 200 centimeters every 10 seconds. Determine the equation of the sinusoidal function that would model the situation, assuming Owen reaches his first maximum of 6. So this is actually really funny. Wait, what? Okay. Because, wait, the whole, like, springy part doesn't happen for the whole thing, right? You have kx as a restoring force for one part, and then you have gravity for the next. Is this even legal? I don't even know if this is... I think physics laws might say no. But okay, well, let's do it the way I think your teacher intended it to be asked. So they're saying a minimum height of 2. So that's how much the thing is depressed. The maximum height of 200 centimeters, that's way up here. But also, That's not dude, the trampoline is not stretching out 200 centimeters up.
No.
So what? Okay. But cool. Maximum height every 10 seconds. Okay, so this is a peak to a peak. So we say like peak to peak is the same thing. PP peak to peak. That's equal to 1 period. Not half a period. So peak to trough is half a period. Peak to peak is a full period. So this means that 10 is equal to that. So omega is equal to 2 pi over this. And that's equal to pi over 5. Okay. And then they're saying he reaches his first maximum at 6 seconds. Oh, wow. Okay, so let's find like the amplitude. There's a lot of tricky things here. So amplitude is equal to 200 minus 2 divided by 2. So that's going to be 198 over 2, which is going to be equal to 96. Wait. 99. Yep, that's 99. We already figured out omega. C, which is the midline, is going to equal to 2 plus 200 over 2. So you average the low and the high to get the midline. And that's going to get you 101. Great. So far we have y is equal to 99. I think I'm going to use sine. We're going to have to use a phase factor here in a second. And then this is going to be pi over 5 t. And then here we're going to say like plus something here, right? And then plus the midline, which is 101. Okay. So he reaches his first maximum at 6 seconds. I see. Uh-huh. Okay, so that means I need this thing to be offset. So let's remember what sine looks like, right? So sine looks like this. This is where it helps to understand actually how like the trig functions work. Oh. So sine is 0 at 0, and then it's maximum when this is at pi over 2. This is the max. Okay. So what I need is this thing at t is equal to 6 to be equal to pi over 2. This must be sine of pi over 2. Okay. So that tells me that pi over 5 times 6 plus phi must be equal to pi over 2, right? And, oh, okay, so that's actually pretty cool. So we can multiply that together. That's 6 pi over 6 plus 6 pi over 6 pi over 5 plus phi is equal to 3 pi over 6. Move it over. Or, no. We want it over 5. Oh, ew.
No.
Gross denominators. Very gross denominators. Real content. What's up, Tyree, dude? Sorry, this is 2 pi over 10. I'm going to try to make them... Sorry, 12 pi over 10. What am I saying? 12 pi over 10. And then this is going to be 5 pi over 10. Okay, so now when I move that over, I'm going to get that phi is equal to negative 7 pi over 10. Right? 5 minus 12 is negative 7. Cool. Okay, so now we've gotten our equation. Which is going to be this. And then it's going to be negative 7 pi over 10. And let's just check that. Let's check that makes sense. So when t equals 6, yes, 12 pi over 5 minus 12 pi over 10 minus 7 pi over 10. It's 5 pi over 10, which is pi over 2. And this will be a maximum. And the cool thing we can see here, right, is this is a sine function that has been shifted to the right. Right? So if we were to look at this, and if If this is like, if phi is negative, that means this moves it to the right. And that's why it's peaking at 6, when in reality, it would like to peak at 5, right? If the period is 10, that means the first peak happens at, at a quarter of a period. The first peak happens at 2.5, but I want it to happen at 6. So instead of having something like this, that would be peaking at 6. No, sorry. Something that would be peaking at 2.5. I'm shifting this thing over and to the right such that it peaks at 6. And that's why it's sine omega t minus, what was it? What's your question, Mohammed? 7 pi over 10. Okay, does that make sense, Suba? How we did that? Let me know. And then, yeah, wait. Oh, wait. TikTok. I'm a real person, TikTok. Be nice. Right. This was 101. How can I show that R is non-demurrable? I don't know what demurrable means. What? But yeah, if you want to submit a screenshot of your question, like the bot says, I'll go through it at least. And if I can't solve it, I probably have a friend that can. So go check it out. Okay, and then this would look like, I believe it's going to look something kind of like this, is what I would say. Where this is going to be at 6. Actually, if we wanted to know... Whoa, very cool. If we want to know when this is 0, you could set this equal to 0. We could figure out the time when this is... We can probably figure out the time when this is 0. Let's just do it real quick. Sorry. Pi over 5t minus 7 pi over 10 is equal to 0. Pi over 5t is equal to 7 pi over 10. So that's going to be t is equal to 9 pi over 10. So that's like almost 3-ish. Okay, so like this is going to happen at 9 pi over 10. Cool. All right. Good question there. Thanks, Suba. Yeah, sinusoidals.
Well done.
I actually have a pretty good video on graphing sinusoidals on my YouTube if you want to go check it out. It's a pretty like nice complete video for things. So yeah, if you go to YouTube, whatever, my channel. Ooh, Pluribus is a great show. I've been like enjoying that. I think it's like sinusoidals. Just type in sinusoidals here. Yeah, here you go. Here's like how to graph sinusoidals. Some of these videos, this one has 53,000 views on it. But yeah, go check this out. This is kind of like my little like quick trick on like how to graph sinusoidals. What do I use for solving equations? My head. I don't know.
Good job.
Do you mean like what do I use as the whiteboard? Or like checking my work, I use chat. Chat's great for checking. Oh, that's group world. A neat fact is that if you consider the complex sine function on any open domain, it will not have a maximum on that domain. I didn't know that. That's pretty cool. You heard it here first from Heard It 3115. All right, Lael. This is great. This is physics. And then Johnny, you're next. So hang on tight. We got you. And also, if anybody else has a question, feel free. The queue is low. Dude, the queue is usually not this low. The queue is only three questions. Usually it's like 15. But the website is actualofficehours.com. Go check it out. And we'll help you out with whatever you need to do. Studying for finals, all that fun stuff. Okay, define slope and sketch some examples of slope. I mean, slope to me is like change in y over change in x, right? I would just say this is like delta y over delta x. But in the case of like physics, I would say, but for physics, it's usually a time derivative. It's usually delta something over delta t. And then, yeah, right, this is positive, this is negative, and then this is zero slope. You are lucky, Johnny. Yeah, okay. The slope of a d versus t graph. Okay, cool. So this actually comes from our definition of velocity. So let's remember that velocity is delta x over delta t, where d is usually x, so you can say like delta d over delta t. So this is slope, and that's equal to velocity. Describe 3 ways you know this to be true. I don't know, 3 ways? Ménage à trois? I would say just this, dog. Like, this is pretty good. Yeah, just change in position over change in time. This is slope. I don't know the other 3 ways. The other 2 ways. Let's do a Doppler. Show the undefined two infinities. Yeah, undefined is when something is like infinitely fast. Okay, let's see. Here are the motion of 2 runners graph below. Do they start at the same point? Nope. How do you know? So let's just look at t equals 0. They have different positions. Or different x positions, sure. At 2 seconds, who is ahead? So 2 seconds is probably somewhere around here, right? This is probably like 2 seconds. So in that case, I would say that person B is. Person B, right? And then at 8 seconds... Oh. 8 seconds probably somewhere over here. So we say like here, for instance. That's going to be person A. Right? This person is more ahead. Who is running faster? A is. And the way you can say that is steeper slope. Means faster velocity. Technically, it's not a faster speed. Well, I guess steepness can go both ways, right? You can have like steepness. Is the other thing called like shallow, maybe? I don't know. It's called like steep. Okay, cool. Great question, Leo. Beautiful flat sound. B went for a walk. A went for a speed run. Yeah. B's speed running. Speed running through life. One sec. Let me get TikTok chat working again. It's always fucking up, dude. There we go. Beautiful flat sound. Thank you. Genius. All right. That was Lails. Alright, next one is from Johnny. Johnny. What do you got? Ooh. What do you want me to do with this, Johnny? I see a bunch of equations. You have to balance it. Okay, here, cool. Yeah, let's balance some equations for you. I'm totally cool with that. Let's make that a little like this. Okay. Nice. All right. How to balance. I have another good video on this too. On how to balance things. It's one of my most popular videos ever. Like, if I go to YouTube. Also when things are like harder, because sometimes you have fractional where is it? Here we go. Balancing, yeah. My 2 videos here. Yeah, here. How to balance simple chemical equations. This one has 95,000 views. Pretty good video. And then this one is harder when you have like odd numbers. So this talks about like when you have fractions and stuff, what you need to do. This is a very, very old video of mine. I think, yeah, I made this 4 years ago. Crazy, but yeah. Nah, but it's Redox. Okay. Okay. Yeah, do I need to balance the image? I did look so different. Yeah, I mean, that's me 4 years ago. I was a very different person. I had glasses. I hadn't gotten latex yet. Or latex, sorry. Hadn't gotten LASIK. LASIK. I also weighed probably 50 pounds less. I was telling people earlier in the chat, yeah, I hit my personal best of benching 315 today. But I've been eating a ton to be able to like put on that mass to do it. Okay, so let's do this. So we got I minus. Do I have to balance it with the electrons? Is that what you're saying, Johnny? Like, do you want me to write the half reactions? Okay, cool. That's fine. Totally fine. Let's do it. Okay, so I feel like they're balanced, though. No? Well, okay, no. I see what you need to do. Okay. Okay, so I minus, I'm going to write the half reactions, goes to I3 minus, right? So in order to balance this, I have 3 I's here. I have 1 I here. So I need to put a 3 and a 1 here. Cool? All right, but then if we look at charge-wise, this is kind of screwed, right? Because this is 3 negative things. So this is a -3 charge. This is 1 negative thing, so that's a -1 charge. So in order for charge to balance, this needs 2 additional negative charges. And the way to get that is to put 2 E minuses there. It's AP Chem? Yeah, okay, cool. All right. I know you don't need to put a 1.
Huh?
But, like, I don't know. It looks nice. We'll get rid of it later. Don't worry. Okay. All right, so then let's look at the half reaction for chlorite. Chlorite? Hypochlorite? Is this hypochlorite? I think it's hypochlorite. ClO minus is going to Cl minus. Oh, okay, and they also tell me it's in a basic solution. So if it's in a basic solution, I think I'm allowed to add OH minuses and H's. Re is rhenium? I didn't know that. So, yeah, if this is basic, I think we have access to OH minus, right? You always have access to H2O, sorry. So H2O and OH minus, right? Yeah, it is kind of like A levels. Yeah. Okay, so let's balance this. So this is actually already pretty good, except for the oxygens. Okay. So, I need an oxygen over here. So I believe what I do is, and correct me if I'm wrong here, I think I put an OH minus here. Right? Because that'll balance the oxygen, but now I have an extra hydrogen. So you have to add water on the other side. I can do kinetics for sure, yeah. Submit a kinetics question. There's only 2 questions in the queue. If you want to submit a screenshot of a question you want me to go through, I'll go do it. Let me think how this works. Sorry, so H2O always adds 2 hydrogens and an oxygen. And so balancing out the hydrogens, I would need 2 OHs. And that gets me an additional... Okay, I think I get it. Okay, I got it. I think I got it, yeah. So you want H2O here. So here's the thinking, right? Notice how there were no hydrogens to begin with, right? So anytime I add H2O to one side, I'm going to need to add 2 OH minuses to the other because I need the 2 hydrogens to balance. And then effectively what's happening is I'm adding 1 oxygen to the left and 2 oxygens to the right. So if you do it this way, you end up boosting the right side with a net addition of 1 oxygen. If I did it the other way, so if I did this being added to the left and this being added to the right, this would boost the left side by 1 oxygen. Oh, yeah, they're half reactions. Yeah, exactly, they're half reactions. So, and it's in a basic solution, lost. So, yes, in this case, because I'm trying to add oxygen over there. I'm going to add H2O to the right, and I'm going to add 2OH minus. Sorry, H2 on the left, 2OH minus on the right. Yes, so, no, here's the key thing. It depends, Johnny, on what type of solution you're in, okay? So, if you're in an acidic solution, you're allowed to add H pluses and H2Os. If you're in a basic solution, you're allowed to add OH minuses and H2Os. That's because you always have water, because you're in an aqueous solution. And if the solution is basic, that means there's an excess of hydroxide. If you're in an acidic solution, there's an excess of H plus or hydronium, whatever you want to call it. Yeah. Okay, so watch what... You add H's... Yeah, but you're only allowed to add the H's lost, I think, if it's in an acidic solution. So I think this is the solution so far. One sec, we're getting there. Oh, I moved this over. Yeah, I think that's the argument we make. So this needs to be 2 OH minuses. And then I think we're Gucci, right? Because look, 2 oxygens, oxygen, oxygen, chloride, chloride, 1 chloride, 2 hydrogens, 2 hydrogens. All right, let's look charge-wise if this is okay, though, right? So now I have -1 here, but I have -3 here, right? Because I have a single negative from the chloride, and then I have 2 hydroxides, which are -1. So this is -3. Do I have a chemistry degree? No. My PhD's in physics, but I've tutored a lot of chemistry in my days, and chemistry is like my second favorite, third favorite maybe subject to teach. So I do, and it's all math, dude. It's all math. Everything's math. Okay, so this is deficient by 2 electrons, right? So that means I need to add 2 electrons on this side. Dude, I don't think you add I don't think you add H pluses. I think you add OH minuses. I think because it's a basic solution. Where would the H pluses come from if it's basic? If it's basic, all the H pluses have been, like, neutralized. Right? Something being basic means you have an excess of hydroxide. And, like, a deficiency of H plus. Oh, yeah, I'm doing the last one. Yeah. You're good, you're good. Again, always keep me honest. Okay, so I think this is it. Right? My bad, I read a... No, you're okay, Psychode. I appreciate it. Keep me honest. Okay, so now when you add these two... We're back, chat. What's up, Amir? My new TikTok mod. Keep the TikTok safe, Amir. Yes, Glizzy, that's true, but that's in gaseous form. In liquids, hydrogen as an ion is monoatomic. It's not H2. It's H plus. It's H1 plus, whatever. Single H. Okay, so if you add these together, right? So I think what you end up getting is, so the electrons cancel. This is the cool thing. Is this matches with this. Sometimes these won't be the same. Sometimes, for instance, let's say, like, whatever, like I fucked up and this was a 3, then I would need to multiply everything here by 3 to get 6, and then I would need to multiply everything here by 2 to get 6. You need the electrons to cancel out as well. We got lucky here because 2e is here and 2e is here. So I don't need to, like, put any additional multipliers on things. So I think the final thing is H2O plus 3I minus plus ClO minus goes to I3 minus plus Cl minus plus 2OH minus. I think this is it. Notice that, yeah, we canceled out the electrons because I didn't need those. And then I think you keep this. We can check this with ChatGPT though. Let's try to get it. Is this called the net ionic equation? Is that what I'm looking for? Chat's pretty good at chemistry. I just want to check. Good. It wrote that. Good. Yep. See, the H2O. It did it. So, yeah. Nice. So this is it. Cool. 1K likes. Thanks, Amir. Appreciate it. Okay, so I think we got the same thing, right? Yeah, let's look. Yeah, right. 3I minus, ClO minus, H2O goes to I3 minus, Cl minus, 2OH minus. Yep, nice. Good job, everybody. Yeah, so if something's a basic solution, you balance it with OH minuses and H2Os. Here, I mean, there's only one other question in the queue. You want me to do an acidic one? I'll do an acidic one for you. Which one? You pick. 2 through 4. Pick whichever one your heart desires. Number 2 looks difficult. All right, let's do it. Today we learned, yeah, rhenium. Okay, let's do this. Let's do this. Oh, fuck. Oh, no. Oh, dear. Oh, bother. Okay. All right, so the half reactions. You have ReO4 minus is going to Re. Okay, so right off the bat, so this is acidic, so I'm allowed to add H pluses and H2Os. And when I do this, because I need the hydrogens to balance, I'm going to add 2 H pluses. Okay, I need more oxygens over here, right? So I'm going to put 4 H2Os, right? That'll get me the 4 oxygens I need to balance with this. But if I put 4 H2Os here, I need to put 8 H pluses on the left, right? Because this has a total of 8 hydrogens as well. All right, now let's look at the charge. So this is +8, -1. And then this is neutral. Very cool. So this is going to be a -7 overall. So that means this side needs to have 7 electrons. Good so far? It's funny how, like, once I do, like, one of these, I, like, warm up my chemistry legs, and I'm like, oh, okay, I remember how to do this. Would this be done with electrolysis? Yeah, I mean, yeah, electrolysis would work, yeah. Electrolysis is usually forcing a potential with, like, again, electricity, because it doesn't want to happen naturally. Would it be 8 electrons? I don't think so. Because the Re is neutral, Johnny. H2O is neutral. But here, I have 8 positive things and 1 negative thing. That gives me an overall charge of -7. Oh, sorry. Wait. Ooh, I fucked up. Sorry. This gives me an overall charge of +7. Ooh, okay. I need the 7 electrons over here. Sorry, my bad. +8 -1 is not -7. Oh, man. We're making mistakes today. Okay. It's okay. I make mistakes. Okay. So I think this is correct. Right? Because now you have -7, -1, +8. Where would we be without stoichiometry? Stoichiometry is goated, honestly. Okay, I think that's correct. What's up, Coast? How am I doing? I'm having a great day, actually. I'm very pleased with today. Today's been a great day. Okay, let's look at the next one. So, IO minus needs to go to IO3 minus. Fascinating. So I need to add an additional 2 hydrogens here. Or 2 oxygens, sorry. So I need 2 more H2Os. So I'm going to say 2 H2O plus that. And if I add 2 H2Os, I need to add 4 H pluses here. Right? To balance out the hydrogens. Alright, now let's see if Dr. Gold can do math. What's going on? These are redox reactions I think we're balancing. One of the students submitted a chem problem. So, we're doing some chemistry. So this is -1. This is -1 and then +4. Oh, this is gonna be a fucking heater. Okay, so this is now +3, right? So how do we get to +3 to -1? I gotta add 4 electrons. I can imagine this be used a lot in chemistry and advanced technology. Yeah. Okay. Cool. I think we're good so far. Okay. So then here are my 2 reactions, which are unfortunately pretty ugly.
You don't know stop it, Aaron!
Okay, so I gotta find a common denominator between the electrons, because you need the electrons to cancel. So, in this case, this is 4. In this case, this is 7. The least common multiple of those... Is it 28? Is it really 28? I think it's 28. Yeah, okay. So I need to multiply everything here by 7. Ugh, that's gross. Okay. And then I need to multiply everything here by 4. Okay. So now we're going to get... If we multiply everything through, I'm going to get 28 E minus plus 32H plus 4ReO4 minus. And then here, let me add the other stuff as well. And then we're going to say plus 14H2O. What were the plus 4s? That was to balance out the H2Os from here. 14H2O plus 7IO minus. Okay, we've gotten everything on the left side. Okay, we're good. And then this is going to be 4 REs plus 8 H2Os. I gotta make sure I get all my numbers here correct. And then this is plus 7IO3 minus plus 28H plus 28E minus. Loses electrons, oxidation. The lion gains electrons, electrons reduction. Leo the lion goes grr. Oh, that's fun. In Texas, we learned oil rig. Because Texas is the oil capital of the United States. Which is oxidation is loss, reduction is gain. It's just an easier one. But I like the lion goes grr. That's kind of cool. Yeah, Leo goes grr. That is so European. Are you European, Big Lizzie? That sounds European to me. Attaboy, Leo. Okay, so from this massive clusterfuck of things, the nice thing is that the 28 electrons cancels with the 28 electrons. And so I think what we're finally left with is, yeah, 4ReO4 minus plus 7IO minus. Wait. Oh, some of the H pluses are going to cancel, actually. What am I talking about, right? Yeah, look at this. If you have 32 H pluses here and 28 H pluses here, does that mean you only have a net of... fuck, wait. Yeah, wait. Yeah, don't I have a net of 4 H pluses on the left? Right? I think so. 32 H pluses and 28 H pluses means now you have 4 H pluses on the right. And then 14 H2Os versus 8 H2Os means you now have 6 H2Os on the right. Okay, so we got rid of this. We've dealt with this. We've dealt with this. And I've dealt with this. Okay, great. Okay, and then this goes to 4RE plus 7IO3 minus. All right, let's just see if that makes sense. This looks like a lot of oxygens, right? How does this work out then? Sorry, what? Yeah, but I got 21 oxygens here, and then I got 6 and 7. That's 13, and 13 plus 16 is 29. Wait, what? Oh, no. Uh-oh. Where did we mess up? 14 hydrogens. Wait, 14 H2Os. Oh, this should have been 16 H2Os, not 8. Oh, this is wrong. Yeah, this is where things are getting tricky. Yeah, this is 16. Okay, so there's actually 2 H2Os on the right side. Sorry, my bad. Yeah, no, I think this is correct now. Yeah, I multiplied this by 2. I should have multiplied it by 4.
You done messed up, Aaron!
Okay, now let's look. Okay, so now this is... And then, wait. This should be 2 H2Os. 2 H2Os. Dog. There you go, okay. This is 21, 23 oxygens. This is 16 plus 7, 23 oxygens. All right, we're good. 4 hydrogens, 4 hydrogens. Great. 7 ions, sorry, 7 iodides, 7 iodides. And then 4 rheniums, 4 rheniums. How long should I be taking with this question? Dude, this is at least like a 10-minute question. At least 10. Nice. Okay, cool. I think we did it. Let's have chat. I want chat. I really do want chat. Like, do this real quick. Come on, Clanker. Solve this. Oh. Lennon Cerner. We'll work with you. Let's just see. I want to see. Yep, least common multiples 28 by 4 by 7. Final result is this. Let's see if it's right. Yeah, looks good, dog. Nice, great. Let's go. Cool, Johnny. I will save these to our Discord, so make sure you go join our Discord so you can go see the solution. And then also all of these. And then Cerner. Oh, dude, and Cerner, you're gonna hurt me with this, dude. I already see what we're doing next, dude. I hate those. It's okay. But then all the recordings for the streams are on either YouTube or Twitch. If you ever want to go back and watch what we did. Thanks. You'll do some yourself? Yeah, go for it, dude. Again, ChatGPT is great for checking the answers. So, highly recommend you do what we did, right? Just try and do it yourself. And then at the end, just see, yeah, what did chat get? And then that can kind of help illuminate any potential errors. I hate them too. It's okay. What's going on in my Discord chat? Sorry, what are you guys talking about? She has none, then don't force them, bro. What are you guys talking about? Chick-fil-A sandwiches? What are you guys talking about in chat, dude? What? Okay, I don't know what's going on. Y'all just keep talking. I do want to actually contact some like fast food companies. You know, like Taco Bell apparently like funds like bands. Taco Bell funds touring bands. Yeah, Feed the Beat. So they have this thing where they feed touring musicians with a $500 gift card. So like, why can't I get a $500 gift card to like give out to students? I think this would be pretty sick, right? Oh, they only selected 100 artists. Oh, okay, so we'd have to like kind of fight for it. I was like, y'all want to start a band and get a $500 gift card for Taco Bell? Well, I'm just real good. Like, dude, I have some students that talk about, you know, they're hungry and there's nothing in the fridge. And mom and dad are both out working because in this economy, dude, you need dual incomes. And I think to myself, man, it'd be kind of nice if I could help them out. And, you know, at least, I know it wouldn't be the healthiest of food, but at least it's better than, like, going hungry. Yes, I would eat all the Taco Bell myself, dude. It's a big risk there. I don't know. I feel like my life would collapse if I ate $500 worth of Taco Bell. You can't do that. You shouldn't do it.
No.
Don't do it. Okay. Let's do some thermo. Also, do you have the answers to these in Cerner? So I can double check that I'm correct or not correct. At least it's an ideal gas. Okay, cool. They didn't give them? These bastards. You know what I can do? Hey, let's just send it in the chat. I'm just going to have chat do it while we're working. We're going to try and do it ourselves, but I'm going to have chat chew on it. Yeah. Well, I guarantee this is actually probably from another exam. You ever done, like, Google image search, right? Y'all kids know how to do this, right? You just... If I paste this in, where does this show up? Well, first of all, Gemini just does it for us. Like, okay, but I don't need that. Well, thank you, Gemini. But I want to know, like, where this has been done before. Exact matches. This is what I want. No exact matches. Oh, interesting. Okay. Okay, well, AI had a solution for it, so... We'll check it later. You know, actually, we'll reference Gemini and we'll reference ChatGPT. Oh, it's an old final. Okay, so yeah, this is definitely not anywhere. Okay, but I mean, this is okay. This is called a PV diagram. I believe the area of this is like the network done on the system. I just remember certain things about PV diagrams that are like annoying. Okay. So, what is the temperature of the gas when it's in state A? Okay, they want us. All right, so let's do question first thing here, which is like, what is the temperature here, dog? Right? Temperature equals question mark. All right, let's see what we have. Okay, so 0.06 moles. So we know N is equal to 0.06. That's useful. The gas starts at state A. Cool. So, let's write down some stuff. Right, so for state A, N is equal to 0.06, V is equal to 1, okay, and then pressure is equal to 1.5 atm. Okay, so I think right off the bat, you can figure out the temperature at state A just using PV equals nRT, right? I think PV equals nRT for question A, right? And so, what do you get? 1.5 times 1 is equal to 0.06. What is R? Is it 0.0821? Is that what it is? What's R? I forget. It's the one that's in atmospheres. Where's liter atmospheres? Yeah, 0.0821. Okay, cool. 0.0821. Okay, then we just solve for T. Oh, this is basic, right? No? Yeah, we're gonna have to talk about the processes that happen in between. I know where this is gonna become a pain. All right, 1.5. This is an ideal. Yes, this is ideal YouTube. It's also the ideal gas law. So it is ideal YouTube content, and it is also the ideal gas law. Cool. All right, so that's 304.5 Kelvin. Great. How much work is done on the gas from A to B? Okay, so let's figure out what's happening at B. Okay. Then the pressure is doubled to reach state B. Okay, so let's look at state B. So state B, N is still 0.06. V is still 1. P is now equal to 3. Okay, and they want to know how much work is done on the gas and how much heat energy is added. So, correct me if I'm wrong, but I think you're a big electrolysis guy. Thanks for the sub, Scratch Man. We're close to 11K, I think. Where are we? Where are we, guys? Where are we? We're super close. Well, one second. I just want to see real quick. Studio YouTube. Ooh. Oh, no. We're 45 away. 45 away. Okay. We get... I would like 11K by the end of the year. That would be fun. Okay. Work is equal to the integral of PDV, I believe, right? The volume is not changing, but the pressure is. So I think when this happens, you have to say that, oh, PV equals nRT. So P equals nRT over V, right? So now you can substitute this, I believe, like into here, and you get the integral of nRT dV over V, which, okay, this comes out, right? Because do they say it's at constant temperature? No, that's the isothermal expansion to state C. One sec. Then the pressure is doubled to reach B at the same volume. What is the work done? I think the work done is 0. Let's see. What did chat get? Chat got 305. Work is 0. Cool. All right, yeah, I was right about that. We're going to use this for later. I'm going to save this. We are going to need this later. The reason why I didn't want to use this equation in Cerner is I don't know if T is constant over the volume. They didn't say it was isothermal. So you can't really use this, but we are going to use it when we go from B to C, because then they say it's an isothermal reaction, and then we're good. Yeah, this is where like there's some math involved. You got to understand how calculus works, right? Okay. Okay, so work is equal to integral of PdV, and they already tell me what pressure changes is, right? But dV equals 0. Can we pause? Why is this the same exact question as my practice exam? This is sus. Are you in the same class as in Cerner? Do you go to Ohio State? This would be hilarious. Yeah, do you also go to Ohio State? Ha! Wow, wait. Did the two of you just randomly find my... Did what? Did y'all find my... They're classmates. That's fucking hilarious. Lamau. Yup. Okay. Welcome. You're probably in a massive class of like 200 people. That's hilarious. Okay. Yeah, so work is equal to 0 here. Isn't it the Ohio State, though, technically? Like, they put the V in front of it. They're like, the Ohio State. It was the same thing at UT. We were like, the University of Texas at Austin. Dr. Gold is taking over the world. He must be stopped.
Bruh. No.
Yeah, stop me. Okay, work is 0. How much heat energy is added? Ooh, okay. Well, okay. If you're not doing work, but you're changing the pressure, I think the internal energy still has to change, which means that heat had to be added. Do we know the change in the temperature, though? Fuck. I'm always tempted to say, like, Q is equal to MCAT. This is what I want to say. But we're not given a C. And we're not given a delta T. All right, let me see what chat says. Oh, yeah, yep. Oh, dude, it does NCAT, dude. But dude, what the fuck is what? Pressure doubles, temperature doubles. Okay, I mean, I can agree with that if it's an ideal gas. Okay, sure. Right. Okay, so yeah. P1 V1 over nRT1 is equal to P2 V2 over nRT2. Okay, these are the same, right? This is the same. We said the pressure is doubling, the volume's the same, so this cancels out as well. If you submit a question, Amir, I'll do it. All right, so P1 over T1 equals P2 over T2. This is like one of the Gay-Lussac whatever fucking laws or something. So if this doubles from 1.5 to 3, this must also double. Okay, so that tells us the temperature. Cool. So P1 So wait, so P2, or PB, sorry. PB equals 2PA. So TB equals 2TA, which is now going to equal to this thing doubled. So what? That's 609 Kelvin. Yeah. Okay. Now I want to use MCAT. Never been more cooked in my life than that. Dude, I hate this shit too, dude. Again, I have a PhD in physics, and I abhor thermo. Thermo is awful. Is this chain real? Yeah, what do you mean? This chain? Yeah, this chain is real. This chain is real, for sure. It's like the only kind of real gold I have. Alright, okay. So then, yeah, Q is equal to, I think it's MC delta T, but, oh, man, we don't know the mass of this thing either. Okay, how does this work? Oh, it's NC delta T? What? Oh, okay, wait a minute. Alright. I didn't know this. Oh, okay, okay, wait, actually, I did know this, sorry. Yeah. Okay, internal energy, U. So this is internal energy. Which, by the way, is equal to, I think it's Q plus W. Dun, 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 dun. Oh, wait, sorry, let's leave that. And then, yeah, Q is equal to U plus W. Wait, no, oh, wait, no. Yeah, this is always, dude, it's always like work done by the gas. Okay, they say work done by the gas. So it's Q minus W. Or Q minus, wait. Yeah, Q minus W. Yeah. And then this is work done by the gas. Always have to remember like which one it is. Grind. How many generate ionic? What are you saying, dude? Okay. Internal energy is also equal to this. NCV delta T. Where we know the number of moles, right? That was 0.06. Delta T, so it doubled, so the change in temperature is 304.5. Not gonna round. CV, this is interesting. I guess this is supposed to be known. I don't like that. Were you given this in Cerner? Were you given that this is 5/2 times whatever this funny R is? It has to do with the degrees of freedom, I remember. I thought it's 3/2 kT. For like an ideal gas. Why is it 5/2? It's on the formula sheet? Oh. Okay, fine. Alright. Whatever. Let's just assume that's given to you. Oh, 5/2 NRT. Okay, cool. I didn't know that. I think, yeah, I guess it's CV. It's energy for an ideal gas. Okay, cool. Alright, so 0.06 times 2.5 times 8.3. But you know what's interesting? This is a different R. Didn't we use 0.0821? What, before? It's a different R. Oh, man. Okay, so that's equal to 300 and let's just say 380 joules. Right, okay. So 380 joules is equal to Q minus W, but W is 0. Okay, but I'm pretty sure... Okay, but 8.314 doesn't work for atmospheres. I believe it needs pascals. Right? Yeah, there you go. Right? Yeah, 8.314 only works when you're dealing with joules per mole K, or like, yeah, cubic meter pascals. If you want liter atmospheres, which is what I was given, right? Pressure was in atmospheres. volume was in liters. You need to use 0.0821. That's fascinating. Okay, fine. Yeah, so little side note here. This is for liter atmospheres. And then, yeah, sure. This is for, like, moles Kelvin or something. I don't know. Okay, cool. So 380 joules is the answer to part B. So 0 work. And then 380 joules of internal energy. Let's check. Good. Nice. Cool. Great. All right. Let's see. Part C. How much work is done on the gas in the isothermal expansion from B to C? Okay. This is where I think we're going to use this. I'm so happy. Dude, I thought I was done with this subject too until someone asked a question on it. It's all good. Did you guys not go over this, Indians fan, like, at all in your class? Was it never, like, a homework question? Because that is also disturbing. Okay, so, same thing. N equals 0.06. And then... isothermal expansion. Okay, so, TC equals TB. Isothermal means same temperature. So, that needs to be equal to, 609 degrees K. And then what else? And then volume is now 3 liters. Cool. And then I don't think they tell us anything about pressure, right? Oh, the professor's horrible. He just gives a formula sheet and doesn't elaborate. Damn. Do you guys ever try going to office hours? Like, office hours is great. Usually you have a TA who, like, gives a shit about teaching. Oh, you guys... Oh, that's funny. So you guys have 2 different professors. So they're not exactly classmates. But they are taking the same class. They're different sections, I guess, yeah. Yeah, so in state C, okay, so I have NTV. Oh, so I can figure out P. Right? We can figure out P. Which I assume is going to change. The TAs are great, yeah. Yeah, use the TAs, for sure. Now, I don't think I need the pressure, though. Because again, class average was a 50? Ew. Dude, can this please move over here? Okay, so work done, right? Work is equal to PDV. Since I don't know how the pressure is changing from B to C, I'm going to replace P with nRT over V. So then I'm getting nRT dV over V. You got a 31, Jesus.
Bruh, surprise, motherfucker.
That's not very fun. I'm sorry. Okay. You got a 30.
Yeah.
Well, at least you're in similar company. Okay, so this is cool because I don't need the pressure anymore. Thermo is fucking lame. I agree. Yeah, thermo is hella fucking lame. So now this is integral of dV over V. This is awesome because N stays the same. T we said is isothermal, so from B to C it's the same. So I can pull this all out. I can say nRT integral of dV over V. Integral of dV over V is ln of V. And remember, this is going to be from VB to VC. So nRT, and then we're going to say ln of VC minus ln of VB. Which from your logarithm rules, right? If you have ln of A minus ln of B, that's ln of A over B. We should remember these are log rules. So, you're going to get that the work done is equal to nRT ln of VC over VB. Cool. And we said the volume at C is triple what it is at B. So this is just going to equal 0.06. I guess I want to use the 8.314. Do we want to use the 8.314? Sorry, where's that unit thing? Yeah, it's joules per mole K. All right, that's fine. Sure. And then the temperature is 609. And then it's the ln of 3. Right? Because VC is equal to... VC equals 3 VB. Cool. So let's see what we get from this. Do you know anything about the theory that the smallest particle is magnetic? I don't. I don't really know too much about subatomic particle stuff. That's like a cool, like, cosmological type thing to go into, though. Alright, this is times 609 times the ln of 3. 333.75 joules. Say 0.8. Okay, that's the work done. Is that all they wanted? Please tell me that's all you wanted. Yeah, how much of work is done? Okay, sick. Okay. And then how much work is done in the isobaric compression from C to D? Okay, so like what the fuck's happening at D? So here, this is let's label the parts of what happened. This was like question B. This was question B. This was question A. This was question C. Okay, now let's look at state D. Again, N is still going to equal to 0.06. Isobaric means the pressure stays the same. Okay, so that means that PD equals PC. So I need to solve for this, unfortunately. Okay, fine. And then the volume is 2 liters. Okay, and then they want me to know the work done. Oh, okay, this is easy. Easy. Okay, so, PC, we should have figured out PC here as well. Sorry, let's just do it real quick. So, if you think about it, we would need to, dude, 25 minutes? No. Dude, you can't solve this in 25 minutes. Unless you've already done it before. If you've done it before, then you just go on autopilot. I'm having to remember all this stuff, like, on the fly, which kind of sucks. Okay, here. So, to get PC, use PV equals nRT. So, PC times 3 equals 0.06. I want it in atmosphere, so I'm gonna use 0.0821. You gotta keep messing with the R. That's so terrible. 609, right? Okay, cool. All right, so let's do it. So 0.06 times. I mean, unless you want to just convert all the pressures into pascals at the beginning, but I like atmospheres. There's 4 short... Oh, and 6 multiple choice. And wait, how much time do you have to do the whole thing? Is it a 50-minute class or what? Oh, nice. Okay, so P's 1 atmosphere. Beautiful. Okay, cool. So we can leave this as 1. Beautiful. Beautiful. Which I guess should make sense here. Do we see how... We kind of see how this is all at 1 atmosphere. Ha! You could have just read the graph. We could have just read the graph. Okay, I think you could have just read the graph. What's up, Trollcats? Yeah. Yeah, okay. If we wanted to be funny, you could have read... You shouldn't do that, though, because sometimes the graph is not correct. Okay, so this is at 1 atmosphere. Almost done, champ. Thanks, troll cats. Yeah, we got 45 minutes left. Okay, so now work is equal to the integral of PDV, which, in this is beautiful because 1 atmosphere is 101.3 times 10 to the 3 pascals. I already know this, right? An atmosphere is 101.3 kilopascals. Yeah, no. You don't have to stop cursing. I don't care. This is fine. I just have to keep telling AutoMod that you're fine. It's fine. Okay, so this, and then integral of dV, right, is just going from 3 liters to 2 liters. So that's a decrease of 1. So you get -1 times 101.3 times 10 to the 3. Great. So, okay, fine. -101.3 times 10 to the 3 joules. I think that's right. No, this isn't multiple choice though. Unfortunately, Psycode. Yeah, this one is the short response. Okay, let's see. Did we get this? B to C. We got that. Great. We got that. 101 joules. Wait. No, it should be kilojoules. Oh, fuck me. The volume needs to be in meters cubed. Oh, ew. Bruh.
You done messed up, Aaron!
Oh, I'm sorry. Okay, sorry. Here, so delta V is equal to -1 liter, which is equal to -1 times 10 to the -3 meters cubed. Yeah, exactly. These are nothing like the homework problems. Don't we love that? Isn't that fucking great? Don't you love it when teachers do that? To be fair, though, they did give it to you as a practice test. So, I you know, at least this isn't hitting you on the exam and you've never seen it before. Right? At least, you know, we can go through it here. Okay, cool. Done. So, this is part D. Yeah, you'd be absolutely cooked. Also, why is this positive? Yeah, work done by is negative. Oh, do they want the work done on the gas? Oh, dude, fuck that, dude. Ugh. Do you want to see the show work? Sure, dude. Yeah, join my Discord. Put it in, like, one of the channels. I would crack up. People said it was unfair to our professor. I sent him one a couple days ago with the springs and the momentum. I doubt your professor really grades much of the exams, though. Your professor probably grades like one of the questions, and the TA has to do the rest of them. Okay. All right, so that's joules. Okay, so then let's look here. In the whole cycle, A, B, C, D, A, is the net amount of heat added positive, negative, or 0? Wait, and then what happens from... Lastly, sorry. It returns to its original state along a straight path from D to A. Don't I have to figure out the work done here? It's something like... Dude, isn't like the area of this like the net work done on the thing? I fucking forget, dude. Well, I know that U, delta U is equal to Q minus W. But I'm pretty sure for a closed cycle, thanks, dude. Isn't for a closed cycle, this is 0. So Q is equal to work. And this is where I'm going to get everything confused with like work done by, work done on. You should look at the Splon delay graph. I don't really want to. Okay, so A to B was this. B to C was this. C to D was this. No, wait, no. Sorry, this was heat. Sorry, my bad, sorry. A to B was 0. B B to C was 338. C to D was 400. So, I think the net amount of heat added is positive. I think it's positive. Let's see. Right? Okay, so chat agrees with me. Delta U for a cycle is 0. Q is equal to W net. And the net work done on the gas is positive. Okay, cool. Right, okay, 334. Oh, the other one was negative 100. Yeah, because everything we calculated was work done by. Okay. Yes. And so if W is positive, Q is positive, so heat is added to the gas. And also it says, the line slopes down and left compression. Right, from D to A. Oh, I don't know if I agree with that. From D to A, it slopes up. I mean, chat screws things up too. Agree with this. Okay, so this is kind of the main thing you have to know. So if the clock cycle, if the cycle is clockwise, network is positive. And then yeah, U is, well, this is where it's the weird thing is like whether like W is like done by the gas or on the gas. Okay. Well, anyways, okay, so we're going to say like Q is positive. Here we're going to say W is positive, so Q is positive, Q added, and you can also say clockwise, whatever pattern. Okay, nice, cool. All right, great, awesome. All right, you sent me what happened in the here. Let me download this for you guys real quick. So this was in Cerner again with the fun questions today. Yay, you did it! Yeah, now you just have to do it in 25 minutes. You just have to do it in 25 minutes. You got that, right? Cerner, don't you got that, dude? You got that, bro. I know you got that. Yeah. Yeah, totally. Let's see. You dropped in the comment area. Let me see what this is. Yeah, you for sure, guy. You guys got it, dude. For sure. Okay. So this was the question. Okay, merry-go-round is a disc is mounted horizontally parallel to the ground so it can rotate around the center. Dang, there's so much shit going on this one, dude. What? An adult pulls on the merry-go-round at the opposite edge with a force of that at 21 degrees, which stays at 21 degrees as they walk, pulling while the merry-go-round makes 1/5 of a complete turn. How fast is the merry-go-round rotating omega after it finishes? Ignore any torque. Sorry, is this the amount of work they showed? Is this the amount of work that they showed? Or is this your exam? I'm curious. Yeah, I know most physics departments are fucking ass, at least for teaching. I'm sorry. It's pretty bad. It's because the physics professors weren't hired to teach, they were hired to do research. Oh, this is your exam work. Okay. Well, I mean, this isn't like terrible. I mean, yeah, this is Hey, he uses gamma. See? Dude, I use gamma as well. People here all call me fucking crazy and they're like, "No, you got to use this. You got to use tau." No, gamma. Gamma's correct. I like that you use gamma. Oh, you learned that from me? Oops. No. Okay, never mind. Oh no. Okay, you did learn that from me. Yeah. Okay. But yeah, torque is equal to I alpha, right? And then omega is going to equal omega naught plus alpha t. Oh, which interesting. They just say the amount of turns. So you have to do this. You have to say omega squared minus omega naught squared is equal to 2 alpha t. So you'll solve for alpha by getting the net torque. I is going to need to come from a combination of this and this. Somehow Calc 2 was a more pleasurable experience than physics. If it's taught right, this is a heater of a question. Sorry, is this one of the questions on your exam? This to me would be, so when I taught physics at UCLA, this would have been like the only free response question I would have someone do. Maybe there would be a second one. It certainly wouldn't be question 10. This is super intense. Because you need to do this, and then you need to get alpha from this, which you have to do sum of torques, which, yeah, whatever, this is 240 sine, is that sine of 21? I think it's sine of 21 degrees, right? No, cosine, right? Because if it was 0, it would be great. So cosine 21 degrees. And then I here needs to be like, you have a cylinder, you have 2 cylinders, so you have to know like I of like the Mary plus I of the child, and then you can solve for alpha. 28 points out of 100. Okay, so it is significant at least. It's at least like almost a third of the exam. But yeah, now I would make this like 40 out of 100. Yeah, I'd make this like 40 out of 100. It's a lot. It's a cool question though. I muted myself. Sorry. I appreciate the question from like the professor point of view because it is super rigorous. You have to know about torque. You have to know about moment of inertia. You have to know about rotational kinematics. Yeah. They gave a false sense of security with the first midterm being too easy. That's the worst.
That's dope.
No, that's not dope.
No.
Yeah, that's terrible. Okay. Yeah, this would be a cool question to do, by the way. Like, if you ever want me... If you have a final exam coming up and you need to, like, know how to do this, like, please. I'm happy to run through it. It's actually kind of fun. Yes, exactly, Psycode. I agree with Psycode. It is long, but it is approachable. It is doable, for sure. Yeah, the thermodynamics... The thermodynamics just fucking blows, dude. I just don't like thermo. Like, look at all this shit we had to write. And then I have to, like, look shit up half the time because I'm like, wait a minute. What's isobaric? What's isochoric? What's like, I know isothermal is. Yeah, you didn't have the time. Well, I'm glad you wrote stuff down. Writing stuff down is great because even if you wrote down like this amount of stuff, hopefully your TA should be like forgiving and give you some leeway. Okay, cool. Ooh, a rate question. All right, let's do this. This is a chemistry question. Anyways, good luck, lads. The Ohio State boys on your physics exam. Hopefully it does not deter you from doing more physics in the future. Okay, great. Here are the rates. Calculate the rate constant and give its units. Cool. Well, I think I need to know the rate. Do I need to know the rate? I need to know the rate here to solve for this. Right? Because I know the concentrations, right? You can't calculate the rate constant without knowing the rate. Yeah, how do you do this without the rate? You can't do this. What's up, Cater? Someone's giving me impossible chemistry questions. I'm pretty sure you need the rate for this. Jason, you have... Okay, here, let's ask chat. I'm pretty sure this is, like, incomplete. I'm pretty sure I don't have enough information to solve this. You're exactly right. Written, there's not enough information to calculate K. To solve for K, you must know an equation for the rate. Agreed. You can determine the units, though. That is true. That's actually kind of cool. Right? Because rate needs to I believe that needs to be in like molars per second. So that has to equal to K. And then you have molarity squared, molarity cubed. So then K must be... We'll definitely need seconds on the bottom. And then you need to just have a single molarity on the top. So you need to cancel all but one of the molarities on the top. So... from here. So this is going to be M4. Yeah, the rate has to be in the previous part. Okay. Anyways, okay. We can determine the rate constant. Yeah. Okay. Yeah. Right, M4. Yes, nice. Okay. All right. Jason, if you want to give me another question with that, that's fine. Otherwise, let's see. Kasey. What's up, Kasey? Ooh, more physics. Let's do it. I like physics. Again, if anyone wants to add a question for us to go over, the queue is about to be empty. I know it's because it's the end of the school year. Like, you guys are done with exams. Unless you're at MIT. But website for that is actualofficehours.com. Go there to click. You can drop a screenshot of your question, enter it in. It'll get added to the queue. Also, make sure to check the streaming schedule here. So this is a live calendar that shows all the events and streams happening this week. So you can find out the next time that we're streaming, when you can get help, all types of fun activities. And then while you're at it, make sure to go join our Discord, because that's the best way you can find out about all the fun stuff. We're going to do a giveaway next. It's either on Friday or next week. I'm going to give out a bunch of cash just to like celebrate. We've had so many awesome things on the YouTube, the Twitch, the Discord, TikTok. Everything's been really awesome this year, and I'm feeling generous. So come on by. We'll have fun. Yeah, part D. Yeah, you need the rate. All right, let's see this for Kasey though. A stone on a string is moving in a circle as shown below. Okay. At point P, the stone has a mass of m but a speed v in the y direction. A quarter of a revolution, the stone at Q has a speed v in the x direction. What is the change in the y direction only of the magnitude of the momentum of the stone? Okay, cool. So, momentum, let's not use red, that people don't like that. Okay. Momentum, which is a vector, is equal to mv vector, right? So, at this point in time, this is going to have... What is the change in the momentum? I think it's just... Wait. Yeah, okay, wait. So, the momentum goes... Wait, what is the change... Oh, of the magnitude of the momentum. Wait, but they say in the y... Dude, I'm so confused here. They say the magnitude, but in the y direction only? Oh, man. Technically, at this point in time, this has no velocity in the y direction, right? So, the py here should equal 0. Py here is just equal to mv. So, I feel like the change should be equal to this. I think it should be equal to this. I think it should be equal to b. I guess magnitude. Yeah, they don't care if it's positive or negative. Does that make sense, Kasey? Yeah, the wording. Yeah, the wording is the worst, dude. Yeah, what the hell is this wording? I get that it's international baccalaureate, but like English, please. Yeah, okay. Okay. Can you explain? Yeah, sure, man. Okay. So let's remember that momentum is mass times velocity, and velocity is a vector, okay? So if we look in situation P here, the velocity vector is only in the y direction, okay? So py equals mv, px here is equal to 0. And sorry, I'm not talking about point P as P. This is momentum. Then at this point in time, right, now your velocity vector is pointing straight to the right. So py is equal to 0, but px is equal to mv. So your momentum in the y direction went from nv to 0. Because velocity was up, down, and now velocity is only left, right. Does that make sense? I need some coffee or something. I'm gonna grab a Red Bull after this. Okay, let's go look at the next one. Two spheres, X and Y, are moving towards each other along the same straight line with momentum magnitudes px and py. Dude, this is even worse, dude. What? X and Y is usually a direction. What? Dude, what? Why are we... Dude, label them A and B, you fucking cocks. Why would you label X and Y? It's terrible. Okay. The spheres collide and move off with momentum P... little... Dude, what? Why is the capitalization of the P signifying... This is triggering me, dude, right? Yeah. Dude, no.
No, God!
What?
No, God, please, no! No! No!
Dude, this is terrible. Dude, who wrote was this person like drunk? Like, why would you write this way? Okay, if anything, like, it should have been PA and PB, and then like PA prime, PB prime. There you go. IB, if you're listening to me right now, this is how you should write the question. Okay? Not this big PX, little PX. Dude, what? This is garbage. Garbage. Alright. Yeah, this is universal, dog. What? Dude. Alright, I'm sorry. Okay. The spheres collide and move off with that. Okay, which one is the correct statement of the law of conservation of momentum? Okay, so total momentum before has to equal total momentum afterwards, but momentum has direction. That's the key thing here. So, these are magnitudes, so they don't encode for direction. You have to put a plus or a minus on them to say whether it's moving to the right or it's moving to the left. So, in this case, right, this is positive. We're going to call to the right positive and to the left negative. So this is positive momentum and this is negative momentum. So the total momentum here would be capital P minus capital... So capital PX minus capital PY. So that's the initial momentum. Okay, so initial. It's capital PX plus minus capital PY. Okay. And then let's look after. So in this case, they're both pointing to the right. So that's going to be little px plus little py. Okay, so answer choice is B. The reason being is that the plus and the minus, Kasei, that tells you whether it's moving to the right or left, is whether it's positive or negative. Okay. Does that make sense, Kasei? It's terribly written, but yes. Yeah, that one was pretty easy. I agree. Okay, cool. Nice. You got another one? Yeah, dude, you're the only person in the queue, dude. Like, keep sending them, dude. I got 20 more minutes of teaching. I think, right? Wait, when's my next student? Yeah, you good. Yeah, I can go till 6. All right. And Cerner's like, I'm gonna get you too. Cerner, what are you gonna get me for, dude? All right, let's do this. All right, more stuff. All right. This one isn't bad. I don't think so. Okay, thank you. All right. All right, let's finish. Let's do this one from Kasei. Then in Cerner, you might be the last one. We'll see. All right, dude. Oh, wow. A fan and a sail are mounted vertically on a cart, which is initially at rest, as shown. When the fan is turned on, an airstream is blown towards the right and is incident on the sail. The cart's free to move with negligible resistance forces. After the fan has been turned on, the cart will... I feel like it doesn't move. This is a tricky question. Does it? I think it doesn't move. I think it remains at rest. My thought process behind this is that, so in order for the fan to push air, it feels a force of the air pushing it backwards. And then the sail feels the air pushing it forwards, but these two cancel each other out. So I believe this is 0. What do we think, chat? Chat thinks this is 0 as well? This goes into like Newton's third law of like equal opposite reactions, right? So if you exert a force on something, something will exert a force back on you. In this case, the fan is exerting a force on the air to push the air. The air pushes back on the fan, and those forces have to be equal, right? So these two have to equal each other. And so, yeah, it is C. Nice. Okay, cool. Yeah. Right? Oh, okay. Cool. Nice. But then my question is, wait a minute. What if there wasn't a sail? If there wasn't a sail, I feel like this thing does move to the left, though, right? This thing moves to the left for sure, right? Why is that? Oh, that's conservation of momentum. Well, no, there's an external force, right? No? Oh, yeah, duh. What am I talking about? Sorry. Okay. Yeah, sorry. I had the right idea. It's not conservation of momentum. Where's my color picker? Give me colors. Okay, so let's pretend for a second that like this thing was not here, okay? You know that this would be propelled to the left, right? I mean, this is how like a basic one of those like airboats works. Okay, because here's what happens. The fan exerts a force on the air. So fan on air, which pushes air to the right, and by the same token, the air pushes on the fan with a force to the left. So if you look at the net force on the fan, the only force on the fan is the force from the air pushing it to the left. And so that's why this thing accelerates to the left, if there was nothing here. If you remove... Sorry, if you add the sail, now what happens is, here you have... here, we'll say like fan on air. Air on fan, right? Which, looking at... Whenever you do like a force diagram, whenever you're figuring out like F net, you only care about the forces acting on the thing, not by the thing. So, while the fan is exerting a force on the air, I don't care about that for a force diagram. I only care about the forces acting on the object, which in that case is the air on the fan. And that's why this thing would move to the left. However, when we look at the sail's just chilling, right? The sail is gonna feel the force of the air on it. On sail. Okay? And by the same token, the air will feel the force of the sail on the air, but we don't care about that. We don't care what's happening to the air. I care about what's happening to, like, the things in the boat. In this case, now the sail feels a force from the air to the right. So the net force on my machine is now equal to 0. This is really cool. I really like this, actually. This is fun. Yeah. So this thing will not go anywhere. Because any amount of, like, thrust you get to the left from the fan gets countered by the sail catching that wind, trying to pull it to the right. Very cool. All right. Moves at rest. Okay. A brick is placed. Yes. The disc is rotating at constant speed. The brick does not move relative to the disc. Which of the following represents the horizontal forces acting on the brick? Okay. There is no force outwards.
Surprise, motherfucker.
That's not true. That's a fictitious force. So if the disc is rotating and the brick in this case is also rotating around, okay, that means it's experiencing acceleration. Namely, it's experiencing centripetal acceleration towards the center. So when the thing is here, it feels acceleration that way. When the thing is here, it feels acceleration this way. And when the thing is here, it feels acceleration this way. In order for there to be an acceleration, we know from F equals ma that I need to have a force. Every time I have acceleration of an object, some force has to provide that. And that, in this case, would probably be the force of friction, or like the glue, or whatever's like holding it together. And that needs to point in the same direction as the acceleration. So that's why it's choice D. The brick does feel a fictitious force that it wants to get launched off. It wants to get launched like out from the disc. But that's not a force acting on it. That's technically a it's called a fictitious force because it's like it's a frame of reference question, where in the frame of reference of the disc, if the disc were to rotate, this would feel like it's sliding out because it needs to go here, but it doesn't want to. It wants to kind of just like kind of stay where it's at. So relative to the disc, it feels like it's getting pushed outwards. Okay. But the main thing to the way you do these so quickly fascinates me. You're so helpful. Thank you very much. Yeah, you're welcome, dude. I mean, to be fair, I've also taught this at UCLA many times. And I've taught this tutoring for decades. Literally decades at this point. So, yeah, I appreciate it. But also, I know. Because I do this all the time. Okay, let's see what else we got. Incerner, Goofy Goober's Holiday. Okay, what's this? Alright, let's see this. Where to send homework. There's a website, actualofficehours.com. I only have 12 minutes left, though. I do have to go after this. But submit it anyways. It'll get added to our Discord queue, which might get answered by one of my awesome other actual educator friends. And also make sure when you go to that website, there's a schedule for all the times we're streaming this week. So if you need more help throughout the week, we'll be on. Especially tomorrow. Okay, a mass is attached to a spring constant of that. The mass is pulled out to a distance that from equilibrium and launched at t equals 0 with a velocity of that. If we want to express the resulting motion in this form, what are the constants a, omega, and phi? Begin by finding the total energy of the system. Oh, okay. Wait, so it's pulled out. Wait, so you have 1/2 k. Yeah, so you have 1/2 kx squared. So it's pulled out to a distance from equilibrium and it's launched. Okay. Is this towards the center? Or is this not? I feel like this is away, because this is positive as well. Right? X naught would be positive, and then it's launched even more positive. Okay. What time zone? Los Angeles. Pacific. Yeah, no, I agree with you. Okay, so... yeah, so this thing is stretched out... 0.3 meters, and in addition it's also being launched with the velocity which is equal to 0.8. So yeah, if you want to find E tote, I'll show you why we need E tote. So E tote is equal to 1/2 mv squared plus 1/2 kx squared. I need numbers for that. So 1/2 1.2 0.8 squared plus 1/2 10 times 0.3 squared. What'd you get for your energy? What'd you get for your total energy? I just don't want to calculate it. It's gonna take me too much time. If you have it, let me know if you have it. Otherwise, I can try to do it manually. Dude, you hate summer? It is not summer here. 0.834? Okay. Okay, I agree with that. Cool. All right. Oh, you're in the southern hemisphere. Yes, you're in Australia or something. I would trade. Okay, so E total is this. Yeah. Okay, so here's the cool thing. So this tells me. So I want to figure out what the maximum displacement is, right? So maximum displacement is in 1/2 k x max squared is equal to 0.834. Right? Oh, Brazil. Oh, Brazil's sick. I have a friend who lives in Manaus. I think he lives in Manaus. I need to go visit him. Square root. Okay, so the maximum is 40.8 centimeters. Right? Is that right? Yeah. Yeah, it's probably even hotter. Cool. All right. And I'll assume you got omega right, because omega is equal to square root of k over m, right? So, okay, cool. So the amplitude is, so this thing has velocity and stretch. Eventually it will have no velocity and it will be stretched out the most. And then that's our amplitude. That's how far out it goes. Okay. So yeah, so you have x of t is equal to 0.408 cosine, what did you get? 2.88 t plus phi. Okay, cool. So if you want to figure out phi, this is cool. You know that at t equals 0, you need this to be 30 centimeters. Okay, so at t equals 0, x needs to equal 0.3. Math is a struggle sometimes, dude. I agree. So 0.408, and then it's just cosine of phi, right? Right, because this goes away. So then phi is equal to the arc cosine of 0.3 over 0.408, yeah? Yeah, they gave you a point. That's how you figure out the phi. Yeah, cool, dude. 408. That's in degrees. Let me do this in radians. Or whatever, just multiply by pi and divide by 180. Okay, so 0.75 should have been the phi. It's a cool question, though. I like that one. Nice. All right.
Well done! Well done!
Boom. Yeah, it's all the same class. Yeah, it looks all the same. Is that gonna be on your final? Yeah. Oh, I don't know why the TikTok chat's doubling up. All right, whatever, it just fucks up sometimes. It was from a quiz. It's a cool quiz question, though. Dude, finals week gonna be gonna be exciting. Why is it gonna be exciting? Goofy, what do you got? Ooh, solve for roots. Let's do it. Love it. Great question, Goofy. I can probably do this one real quick. Okay. First thing I notice is I can pull a 6 out of everything here, right? That just makes my life simple. So I'm going to say this is 6 x squared plus 12x plus 20 equal to 0. So we can just get rid of the 6. Okay, so you have x squared plus 12x plus 20 equals 0. I like to, like, move this stuff all over here. And, like, we'll deal with this thing later. Then what you do is you take this, divide by 2, which will equal 6, and then you square it. And then that becomes plus 6 squared minus 6 squared. This is the same thing as adding 0, so we're okay. Now I can group this as x plus 6 squared. But keep in mind, I still have minus 6 squared and then, like, plus 20 all equal to 0. So now you have x plus 6 squared minus 36 plus 20 is minus 16 equals 0. Move it over. X plus 6 squared equals 16. Square root both sides to get rid of the square. X plus 6 is equal to plus or minus 4. Whenever you take square roots of things, you gotta put plus minus. So then you get x is equal to negative 6 plus or minus 4, which is equal to negative 6 plus 4, which is equal to negative 2. Or negative 6 minus 4, which is equal to negative 10. There you go. Was that cool, Goofy? I did that kind of fast, so please let me know if you wanted me to slow down and explain any of the steps. No. It's not negative 6 squared. It's minus 6 squared. That's the key thing. When you complete the square, you add a 6 squared and you subtract a 6 squared. So this is going to be minus 36. Yeah. Oh, thanks for the shout out, High Potential. Okay, cool. All right, that was Goofy's. Let's mark that as done. I love completing the square. It's so fun. Yeah. Yeah, you just need to do a bunch of example questions in Cerner on Thermo, so that, again, when you see it, you're not wasting any time trying to remember things. Ooh, I don't know if I can do this in a minute, but I'll see. I'll see how far we can get. Okay. The air tracks are sliding to the right at 1 meter per second. Yeah, just run through them. Just get the muscle memory, dude. The spring between them has a spring constant of 120 and is compressed 4 centimeters. The carts slide past a flame that burns through the string holding them together. Afterwards, what are the speed and direction of each cart? Ooh. I feel like the center of mass has to be the same. Right? Stop the cope? What's the cope, dude? Yeah, for sure, dude. You're more than welcome, dude. Let me fix. Why is my TikTok chat fucking up? Ugh. Okay. So I believe for this one, F equals KX, right? F equals KX, which is going to equal to 120 times 0.04. What's that going to be? Like 4.8? So that's the force. And I think that it gets exerted on each side, right? This one feels a force of 4.8. Oh, I think we can do this. Wait. Isn't P... Right. So P is equal to MV. So delta P delta T is equal to like F net on an object, right? So but I need the change in time. Okay, I'm out of time. I gotta go. This is a fun question, though. I will add that to my Discord to solve later. But, okay, let's close out the stream. All right. right, thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions we had today. You guys are awesome. Good luck with all your finals and all the fun stuff. Again, if we didn't get to your question today, do not worry. We are going to do them later at some point in my Discord. So make sure to go to the website, actualofficehours.com. Click here to join our Discord. If you're watching us on YouTube or Twitch or TikTok, whatever, go follow us on all the platforms. It's free. It helps us out so much. The more followers, subscribers, all those stats makes the algorithm like us more, which means we can help more students because then we pop up on their feeds instead of thirst traps and feet pics. Okay, if you ever want to figure out when we're streaming again, click here for the streaming schedule. Our next stream will be tomorrow starting at 4 p.m. We don't have a stream on Wednesday, but Penn Center will be doing something with Riemann surfaces. If you want to go check that out, Penn's an awesome guy. And then Zach and Penn will do a kind of a math podcast on Thursday. We will have a stream on Thursday, and then make sure you go join the Discord here because I will announce a super fun special giveaway we're going to do for next week. Cool. All right, if you're watching us on Twitch, which is the awesome preferred platform to watch us on, you can go here to raid a channel with us. So if you're just in Twitch watching, awesome. We're going to go say hi to another one of our streamer friends. Let's see who's on. Anybody that I know? Science is starting soon. Let's go say hi to Draw Curiosity. I like her. She's fun. I met her at TwitchCon, actually. Good luck on your final, Jakes. Okay, cool. All right, we're going to go raid Draw Curiosity. So, I hope you guys have a wonderful start to your week. Good fucking luck with your finals. We will see you tomorrow. Peace.
Cozy, thank you. It is pretty cozy. Actual Education, hello. Thank you so much for the raid.
Actual Education raided my stream with 12 views.
Hello, welcome in. How is your stream? Welcome raiders. For anyone who's new here, hi, my name is Inés, rhymes with face. I have a PhD in insect flight biomechanics, and I am currently flailing at a cryptic crossword that we are all doing together. So whether you're good or terrible at cryptic crosswords, feel free to join in. Also, what were you up to? If you've come in with Actual Education, what were you up to? What's your favorite thing about him? For those of you who might not know Actual Education, if you enjoy me as a science streamer, you're going to enjoy Actual Education as a science streamer, and you should totally go drop him a follow. Hi, Actual Education. Welcome in, Wellovexim. Hello, hello. And congrats on your Desert Locust. I was also going to say, if you've come in on the raid, feel free to go nab yourself a daily bug